But again, what's important, and MATLAB, will give you an error if you don't have all these things. You have to put the ends in yourself. Okay. So, for example, if I forgot one of these ends over here, MATLAB wouldn't even execute. It would give me a syntax error saying that you don't have enough ends or it's not matched with the for loop. So again, this for and end go together, and this end is because of this if. Right? It has to know when the tests are over. Okay. So hopefully we should get that graph now when we execute this script. Okay? And again, this is a script, it's not a function, so we run it the same way we did with the plot Bessel. Either put in the name of the thing, or just do run on the guy. Okay, plot piecewise, okay, there it is. Let me just run, and there it is. Right? It's exactly what I wanted, okay? And we no problem if there was a discontinuity at a half. Maybe, when x is greater than half, you want it to be 1. Doesn't make a difference, okay? Okay, so let's see. So we did that. We did, okay, Gretchen. Oh, let me look at another one called contours. This is really cool. Contours.n, okay? We're going to need this next week, okay, when we do what's called direction fields. Let me just open it up now for you. And okay. Remember I told you we had these things like implicit functions, okay? And I think I wrote this actually on the board, not this one or something else. You have some messy function of x and y is equal to 0. And you can't solve this. Imagine that you basically put equals 0 over here. There's no way you can solve this in y in terms of x, okay? But maybe this came up in application. Actually, you know from the physics that it should be y is a function of x, or maybe a multi-value function of x, okay? And you want to get a contour plot of that, okay? And here's basically what we're going to do, okay? So there's the function that I want to look at, and clearly what I want to do is I'm going to do 2 things, okay? There's 2 plots over here, I believe. One, I'm just going to MATLAB plot contours of constant values of that. In other words, look at this function as a function of x and y, and just give me contours. Let MATLAB choose, what the value on the right-hand side is. Maybe it'll be 2, maybe it'll be 7, something like that, okay? And you can tell MATLAB how many contours you want, okay? In the other case, I'm going to explicitly write a number over here. I have to see what I'm doing. I think I do 1.63, okay? So let's start what happens. First thing you have to do is you have to create a rectangular grid where you want to see this contour plot. So I said, let x go from -2 to 2, steps of 0.01, and let y go from -1 to 1 at steps of 0.01. So we now have a rectangle, right, in the xy plane. Okay, this thing I'm not going to go into. Okay, it's crazy mesh grid. I don't know why they made it so complicated. What it's going to do, if you actually look at this, when it does the mesh grid x and y are going to be matrices. And I think x, all the columns will be the same, and y, all the rows will be the same, or vice versa. I forget, okay? For some crazy reason, I don't know, most languages don't make you do this. You have to do this crazy mesh grid once you have the x and the y. So basically, it's kind of, if you take the mesh grid stuff, it'll give you like a grid of x, y values, like xi, comma, yj, all over the grid, okay? So this is just, just do that, okay? Now what you do is, and what I've done here to try to, be a little careful, or not as much careful, but notation. Notice x and y, I put little letters, okay? Because those are vectors, okay? You don't have to do this, okay? When I put a big guy, it's to remind me that it's a matrix, okay? When you look at this thing over here, if you were to do a who's on big X and Y, you'd see that they're actually going to be matrices, whereas x and y are vectors. Okay. Now you code up the function, but you use not little x, little y, you use big X, big Y. And now let's look at this very, very carefully. Okay? Z is what I'm assigning it to. The first thing is sine of 3y minus x squared, right? Now if you were to write this on the board, okay, you would say what? Sine of 3y minus x squared, right? Plus 1, is that it? X squared plus 1. Plus cosine of 2y squared. I'm writing some normal notation. cosine of, what do I got now? Cosine of 2y squared minus 2x. Hopefully you can see that. Okay, that's kind of a normal way of writing that. Well, let's look at the MATLAB syntax on this. Okay, so we have sine, and there's the parentheses to what's the argument of the sine. Okay, 3y is easy, right? It becomes 3 times y. Now remember I said y is a matrix? And that's why MATLAB has that notation. Remember I said if you take a matrix times a scalar, it multiplies every element by that scalar. And that's clearly what we want to do. For a certain point, we're going to have 3 times the y value, no matter where the y value is. So 3 times y is fine MATLAB syntax. It takes the matrix y multiplies by 3. Now, we need minus x squared. Look over here. Okay? If I did minus x without the dot, you know what we'd try to do? It would take the matrix x and multiply it by itself. It probably can't do that because x is not squared. You get an error message. What I really want to do over here, I want to take every element, right? Remember, it's an element by element thing, and square it. So therefore, to get, see, this notation is so clear, but when you get to MATLAB, you have to be careful. I want to square every element of x where it appears. It's an element by element squaring, so to speak. So I do x dot squared. And this type of thing is the most common error. Okay, there's a homework assignment that coming up in a week or two, and my experience has been that when people have trouble with it, they send me an email. It's always this dot that they forget. Okay, so if you're doing something, just keep that in the back of your mind. That if something isn't working because of some dimension error, most probably you forgot something like this. Okay, so again, you just can't do x squared because it's a matrix. You have to do x dot squared. Real pain in the neck. Okay, and then plus 1. That's fine also. But again, remember what's going on over here. Okay. This matrix basically is 3y, that's okay. It's going to subtract from that, and that's a matrix. Let's say it's 10 by 80, okay? Then I take a 10 by 80 matrix and I add 1. Can I do that? MATLAB says, okay, I understand what you want to do. You want to add 1 to every element of that matrix, okay? So this, although mathematically this doesn't make any sense, adding a scalar to a matrix, MATLAB has that convention. You can see otherwise it would be a pain in the neck to code this up. I mean, it's bad enough with the crazy mesh grid and the x dot, okay? So thank goodness we can at least put a plus 1 there and do what MATLAB does is what we intend. We want to add 1 to every element, okay? And the next y is the cosine of 2y squared minus 2x. Again, the y is a matrix. If I want to square every element, I got to do y dot squared. But the x is fine because it's just a multiplication by a scalar. Okay. Now, here comes this new command called contour that's built into MATLAB. You can look at the documentation. The first 2 arguments tell me the x and y range. Notice I use little x, little y. So it knows that the x-axis goes from -2 to 2, y goes -1 to 1. Then the thing that you want to get a contour plot of, okay? But I never said, equals 5 equals 0, right? So here's what happens now. The next argument is 10. It's an integer, no, it's an integer. That tells MATLAB, give me 10 contours, okay? What the show text on does basically is it's going to label the contours with the values. So what's happening over here is that MATLAB, you see, has all the information now. It's got your x range and your y range. It's got the value of the function at that point, okay? Normally that would be a surface, right? But we're going to plot it in a contour. What it's going to do basically is kind of survey, the minimum value of z and the maximum value of z, and then it'll plot basically a sample of those over the range, and it'll give you 10 contours. Okay. Now, of course, if you left off the show text on, you would just see a bunch of curves, a bunch of contour curves, and you wouldn't know the value on them. Okay. Which I'm kind of confused not confused, but kind of surprised that that's not the default. But maybe if you have a lot of contours, it just gets too crowded, something like that. Okay. So we're going to get one thing over here and just say contour plot, and that's the title and font size, whatever I have over there. Okay? So in the first graph, we're going to see 10 separate contour plots. Okay? And you'll see near the contour plot, it'll probably be small, I'll have to blow it up. It'll say something like 3.8. That means that on that contour, that whole mess of that f of xy is 3.8. Okay? It's choosing the value on the right-hand side based upon what's going on with the function in that rectangular grid. Now, usually what happens is that you want to look at a particular contour. For example, suppose this is temperature. You've solved a problem, a heat equation in a plate. and you want to look at the temperature, and in particular, you're interested where the temperature has a value of 1.6363, okay? What you can do is the following. You do contour just like before, X, Y, Z. Instead of getting the number of contours, you enclose in brackets the contours you want to look at. Now here, it's repeated. Unfortunately, you can't just, it's kind of nuts. What happens is that usually you put more in here. Maybe, suppose I want to see the contour for 1.63 and 8. I put 1.63, comma 8. And that'll give me 2 contour plots, okay? Here I just want to do 1, and unfortunately, you have to repeat it. If you just put 1 argument in there, it doesn't work for some reason, okay? But normally, you know, maybe you'll see where the temperature is equal to 20 degrees, 30 degrees. So you put 20, 30, and it'll show you where in the plate. It'll draw a nice curve. Everywhere along this curve, the temperature is 20. Everywhere along here, it's 30 degrees. Isotherms, right? What they call it in the weather world, right? If this was a pressure, okay, it would be, you know, isobars. Okay. So let's execute. The only thing that's new about here is this contour plot thing. And again, the reason I wanted to do this is to show you that it's very important when you do things like a matrix squared, and your intent is to do it element by element. You have to, you know, put that crazy dot in there. Okay, let's run it. See what we get. Okay. I get 2. Here's the first one. Okay. Okay. And you can see basically MATLAB got actually 10 different contours. I guess this yellow here is 1.2727. You can follow along. Okay. Sometimes they're closed, sometimes they're not. And oh yeah, this one was closed. See, that's why I chose 1.6363. See, that's a nice closed loop. What it means basically over here is that that hideous function over there, if you set it equal to 1.6363, here are the points in the xy plane where it assumes that value. Okay? Everywhere along this curve, that hideous function of x and y takes on the value of minus 1.2727. Okay? Now this was the first case where we didn't tell it what contour to draw. We just told MATLAB, give me 10 contours. Okay? And what it did, it sampled the range of this function over that grid and just, you know, kind of gave you a sample from the, you know, from the smallest to the highest, but limiting itself to 10 contours. Okay. Now the second one that I did is I told MATLAB explicitly, only show me the contour for 1.6363. So we should get just a plot of that little oval, right? That's in the second figure window. And again, you'll see that right over here. You see there? It labeled at 1.6363, okay? Good. Any question?
Is there a way where you can have it tell you what the highest number value that equation will reach?
Yeah.
Because obviously it goes higher than
1.6. Yeah. Okay, I'll do that for you. Okay? What happens is that, okay, this thing, you do the max, what's called the max function, okay? This thing called max, okay? And let me just illustrate that for you first, okay? This is all in the memory, hopefully. Let me just do a boost, make sure Z is still there. Yeah, big Z is a 201 by 401, okay? Let me illustrate this max, okay? Let me just repeat the question. The question was basically, we know that Z goes through a whole bunch of values. It's a big array. It has a 201 by 401. Can we find out what the maximum value is in there, as well as the minimum value, okay? And you can. Let me show you, illustrate this by, I'm going to take a little vector, I don't want to destroy anything, V, and make that 167 minus 4, 34, okay? Okay. What's the minimum value of V? It's minus 4, so you do min of V. Min of V. Min of V should be minus 4, right? And the max should be 34, right? So we do max of V 67, okay. Yeah, maximum is 67, okay. Now, we have a matrix, though. It's going to do something kind of weird. Let me just show you. Let me say M, a little matrix, rand 5. I think it's a 5 by 5. Okay? Okay. What's the maximum value in there? It's point 9649, it looks like, right? Okay.
No, there's a 9706.
Where's the 9706?
It's
Third,
column,
second down.
second row.
Third column, second row. 9157.
Left.
Here?
Up one.
Up.
9706. Okay. 9706. Okay. Now, what happens if I do on M, max of M, what it does, if you look at the documentation, it gives you the maximum element in every column. Okay? So it's going to give you in this case, a 1 by 4. Okay? So we have to do max twice. Okay? Do max on a matrix, it gives you the max in each column, and then we'll max that, and we should come up with that number. Okay? So let's do that. So I do max of M. And you said it was the point 9157? Is that the number?
9706.
9706. Okay, there it is. Okay? And similarly, you can do the minimum like that. So to answer your question on the Z now, if you want to find the minimum element in there, min of Z, minus 1.99, and max of Z, two. Okay? So it's always minus 2 to plus 2. Okay.
So each max takes it down a dimension?
Yeah, what'll happen basically if you have a matrix and you do max of that matrix, it'll give you the max of every element in the column. And so you can do things. You also can do things like max of absolute value if you're interested in that. Okay. Okay. We've got about 5 minutes left. I guess this will go into the next session. We did scripts. We did program scripts. Defining functions, contours. Yeah, okay. Let me just, we'll just, this is a very short one, then we'll go. We're going to do basically programs now, okay? And I'm just going to do this it's a very simple program that I wrote. And the important thing here, again, is